Hi, and welcome to section 9.6, solving rational expressions. Here we have an equation number 21 in the homework assignment, so we're going to go ahead and solve it. I'll try to do it as quickly as possible so it doesn't take too long. So let's start from the beginning. The first step is to, we're going to try to get rid of the denominator because it's going to make the problem a lot easier. So the first thing that we need to do is factor the denominator. So this denominator has a denominator of 2. It's got a denominator of x, and this one doesn't have a denominator, so I can take the liberty and put a 1 there. So now all three are definitely going to be fractions. So my first question is, can I factor the 2? 2 has already been factored, so I can't factor it any further, so I'm just going to put a parentheses around it. Now, can I factor the x? X is already in simplest form. You can't factor it any further. I'll just put a parentheses around it. And the 1, there's no need to do anything with it. So I am now going to do an LCD list. So LCD stands for least common denominator. So I'm going to get one factor of each type, and I'm going to make a list here. And this will go ahead, and this will actually give me the LCD of the entire rational expression. So there goes 2. So I'll put a 2 here. I'm done with the 2's. Now I'm going to go to this denominator. We have an x, so I'm going to go ahead and put an x here. So I'm done with the x's, and now I have a 1. I don't have to put a 1 because 1 times 2x is just 2x. So I found out that my LCD is 2x. So my next step is to multiply each term by the LCD. Okay, that's going to eliminate the denominator for me and make this equation a lot easier. So let's begin. I'm going to go ahead and multiply 2x times the first term, 2x times the second term, and then 2x times the third term. Notice I put it in the back here. It doesn't make a difference whether you put it in front or the back. So my next step here is not to multiply. I do not want to multiply 2x times 3. I don't want to do that because my point to doing that was to cancel with the denominator to get rid of the denominator. So if you look closely, here 2 divided by 2 is 1, so that basically means that those two guys will cancel, so the 2's are gone, and therefore my denominator is gone here. Here I have an x and an x. X divided by x is 1, so they also cancel, and I will be using the word cancel quite a bit, even though it's not the official word. It should be simplified, but cancel should work just fine. And here we don't really have a denominator. We have a denominator of 1. We only put it just so it could look nice, and sometimes it does help us solve equations, but there's nothing that it'll cancel down here with. So it looks like we're done. All our denominators are gone, so I'm going to rewrite this. We have a 3 and an x left here, so I'm going to write 3x. Excuse me. I have a 2 times 1 gives me 2. X's have been canceled. And I have here 2 times 2 is 4, giving me 4x. As you can see, the equation got a whole lot simpler. We now have 3x plus 2 is equal to 4x. Now, what I tell people, if you're sort of a beginner doing equations, it's a good idea to put a border or to put a line going down, which basically tells you this would be the left side of the equation, this will be the right side of the equation. It kind of makes it simple when you have to do something to both sides. You know, the left will be on the left, the right will be on the right. So, let's continue. Looks like we have an x on both sides of the equation, so we do have to get rid of one of them. Now, I kind of have a little story that I tell people, and I say, hey, if you were going to get in a fight, would you get in a fight with the 4, which is bigger, or with the 3 that is smaller? And people usually like to joke, and they say the smaller one, the bigger one, but I know they really mean that, you know, if they have to get into a fight, of course you're going to pick the smaller one. So it's a good way to remember that you want to get rid of the smaller x versus the bigger x because it prevents you having negative x's, which just saves you time in the long run. So I'm going to get rid of this 3x because it's smaller. So I'm going to go ahead and subtract the 3x. I do it to the left, and I have to do it to the right, which that's what we do in algebra to solve. As long as we do it to both sides, we're fine. 3x minus 3x gives you 0, so they cancel. So we are now left with 2. To bring that guy down. Always put the equal sign on the dotted line. 4x minus 3x gives me just one x, so I'm just going to go ahead and put x. So it looks like we're done. We found the solution. The solution is 2. Now, because we're dealing with rational expressions, sometimes you do end up with extraneous solutions, which means the solution might not work. So every time you're solving for rational expressions, you have to plug it in to make double sure that this is a solution, because this possibly might not be the solution. So let's begin. I'm going to write 3 over 2 plus 1 over x is equal to 2. Now, instead of putting x here, I'm going to take x off because we now know that x is 2. So I'm going to go ahead and put a 2 there. Okay, we have a 2 there. That's the bell. Sorry for the interruption. I am here at Gary High School. So here we have the same denominator. So when you have the same denominator, you can write the denominator 1s on the bottom and you do the math on top. 3 plus 1 is 4. Write the equal sign again on the dotted line. 2. 4 divided by 2 is 2. I put the equal sign again and I bring down this 2 on the right. There we have it. 2 is equal to 2, which means the left part of the equation is equal to the right part of the equation. Therefore, we did find the solution to be 2, and then we plugged it in, and we found out that the solution was true. It was not extraneous, so therefore we're done. This is number 21 in section 9.6. Thank you.